Buenos dias, ¿cómo están? Welcome back. Welcome to the new year as well. The original plan for today's lesson was to address a problem submitted by one of my younger cousins. Or more specifically, one of my first cousins once removed in the younger direction. At a recent family gathering, my first cousin not removed, his mama, informed me her son was having some difficulty with his math class, or he could use some help with math, or something to that general effect. Talking about could they give me a problem to do an episode on. I said, yeah, obviously. I just told my cousin, if her son ever needed some help, they could always give me a problem to do an episode on. As it turned out, no problem was forthcoming. I can only presume my young cousin is doing fine in his math class. I sincerely hope that's the case. The moral of all of that is we got to go in a different direction. A square, the most famous quadrangle in the history of math, maybe the world. So why is it a square here? It's because in a previous episode, I left some unfinished business. I'm up in here talking about how a parabolic expression is supposedly called a quadratic because it's related to a square or the area or squaring or some combination of that. We may never know. But however that went, I do know I said it won't the whole story when it comes to the relationship between a parabola and the geometry of a quadrangle, particularly a square. So what's the rest of the story? That's why we're here. Or if not the rest of the story, at least the next part of it. All right, let's begin. So last time, I used the example of the parabola of x squared, which came out of a situation of what's the area of this square if the sides is x and x. X times x is x squared. Looks something like that on a graph. Child's play. So here go another square, along with another function expression. Got more letters and numbers than the last one. Nevertheless, it's still a parabola. Cause why? Cause it's got an x squared at the front of it. As you know by now though, that ain't no kind of explanation. So question number one in this new scenario is this really a parabola? Question number two is, can you generate this more complicated, supposedly parabolic expression by figuring the area of a square, like we did earlier with x times x? We'll start with question two. All right, first, I'm gonna divide this square up so it look more complicated. Then I'm gonna say the distance of this part of it is a 3. Because it's most likely 3 or something. Maybe some centimeters. But if I don't really know that, I definitely don't know the distance of this remaining part. So I'm gonna say it's an x. And since this is a square, I gotta make sure this side say the same distances on it. What's the area of this square? I don't know, and neither do you. But I'm sure we can all agree it's gotta be the area of this, and this, all added together. And getting the area of these smaller squares ain't no big deal. Ain't nothing but the length times width of each one. So check it out. This square measure x by x. That's the area of x squared. This square is x by 3. X by 3, that's 3x. This square is also x by 3, 3x. This square down here is 3 by 3, it's a 9. So now the area of this whole square has got to be x squared plus 3x plus this other 3x plus 9. And 3x plus 3x is widely known to be 6x. As you have now observed, we just answered question number 2 in the affirmative. You can definitely generate this more complicated parabolic expression by trying to figure out the area of a square. Because there we go, laid out very plainly, thanks to the smaller squares inside the larger square. So what have we learned? Not a whole lot. But we do know a parabola expression can very logically be related to the process of timesing two sides of a square, even when it ain't quite as obvious as a parabola of x squared coming out of a quadrangle that's x by x. But what about question number 1 though? Is this a parabola? Well, you already know how to work that out, so do it. Or better yet, here go a challenge for next time. You're gonna draw you a coordinate plane. Then you're gonna plug some reasonable numbers into this function right here. Then you're gonna put the resulting points on your graph, connect them, see if it end up looking parabolic. And then you're gonna take your graph drawn to a local museum that's near to your place of residence or your neighborhood. You're gonna go in there, stand in front of a painting of art with your drawing, take a picture of yourself with your cellular phone, or maybe that or one of your fellow patrons. Then you're gonna put the photo up in the comments to prove you done did the challenge. I ain't saying nobody gonna check it, but the point of the challenge ain't to prove you did something. The point of the challenge is you. Oh, what? Maybe you ain't supposed to take pictures in the museum? Well, I guess that's part of the challenge. Due on the 17th of February. Best of luck. Have a wonderful day. Adios.